All right, these are the notes for our work, power, and energy unit in physics, and these are the part 2 notes. So in part 1, we talked about work and power, and in part 2, we're going to talk primarily about energy. Energy is the ability to do work, or that which can be converted into work. And there's lots of different types of energy. We can talk about stored mechanical energy, nuclear energy, chemical energy, or even gravitational potential energy. That's one of the things that the gravitational is what we primarily focus on in this class, and that's the potential energy. That means it's roughly just going to be stored energy of some sort. Then there's electrical and radiant and heat as well as movement. And we are primarily going to be dealing with movement energy, which is going to be our kinetic. So kinetic's really just where it's moving in some way. Electricity, electrons move. Light, again, electrons are moving, creating waves or packets of particles. And then thermal, you have waves moving of heat. So all of this is movement types of energy. So when things have energy, they're able to perform work, or in a general sense, to change some aspect of the physical world. All right. So in mechanics, like our class, we are concerned about two kinds of energy, and those two kinds of energy are kinetic energy, which is energy possessed by a body by virtue of its motion. Really, kinetic energy is all about motion. When we talked about kinematics, we were talking about moving objects. So kinetic energy's formula is Ke equals 1/2 mv squared. Okay, mass will be in kilograms, velocity will be in meters per second. So when you put that together, you end up creating a Newton meter. And if you remember, a Newton meter is really just a joule. So the units of these are a joule. So much like our work, energy is, remember, just a type of work. So it is joules. Then we have potential energy, which we will refer to mostly as gravitational potential energy, which could be done as GPE on some paperwork. So energy possessed by a system by virtue of its position or its condition. So ours is going to be gravitational potential energy, which is mass times gravity times height. So mass is in kilograms, gravity is in meters per second squared, and height is in meters. If you really think about it, mass times gravity is force, and height is just a funny way of saying, or a different way of saying displacement, but it's just vertical. And so this is really just force times displacement. So it's a specialized work. So again, its units are also in joules. So kinetic energy, potential energy, and work are all in joules. So find the kinetic energy of a 3,200 Newton automobile traveling at 20.8 meters per second. Well, we're given force and we're given velocity. Well, the kinetic energy formula actually is 1/2 mv squared. So we need the mass, but if that's the weight of my vehicle, I can find the mass by taking that force and dividing it by gravity. So I can find my mass by doing my weight force divided by gravity, which we use this class 10 meters per second squared. So 3,200 divided by 10 is 320 kilograms. So now that I have that information, I can use my formula of Ke equals 1/2 mv squared, plug in my mass of 320 kilograms and my 20.8 meters per second, square it, and then divide it by 2. And that'll give me 69,222.4 joules. Okay. Now, I can have also a 250 gram object that's held 200 millimeters above a workbench, and that workbench is 1 meter off the floor. Find the potential energy relative to just the bench top. So, first thing, I have to change the mass from grams to kilograms. I can do that by dividing by 1,000 because there's 1,000 grams in a kilogram. Then I also will need to change my millimeters to meters. So I know that there's 1,000 millimeters in a meter, so I'm going to divide my 200 by 1,000 as well. And so once I have this to find potential energy, it's mass times gravity times height. So I do my 0.25 kilograms, multiply by 10 meters per second squared, multiply by 0.2 meters. That'll give me 0.5 joules. That was just from above the bench top to the bench top, but now I want it relative to the floor. So I'm above the floor a meter just to get to the workbench, plus another 200 millimeters. So I'll need to make my height 1.2 meters overall. And now I'll do the same formula, but I'll do 0.25 kilograms multiplied by 10 multiplied by 1.2 meters. So that will give me 3 joules. So the higher you are off the ground, the more potential energy you're going to have. All right, so that is the easy part of energy. It is just two basic formulas, and we just talked about kinetic and potential. All right, should be able to classify the types as well as calculate them. If you have any questions, see it at tutorials.